Okay, so now we are set. Hey everyone, welcome to the stream after a week or so, I guess. Okay, today let's see, we're going to build a compiler for the Czech language. Before we start coding, I think I should read the documentation first. The music is a bit loud. Let me lower the volume a bit. Okay, so this is what our compiler will do. It will convert the Czech language into the machine code, but not exactly the machine code because we have already created the VM translator which will convert the VM code into machine code. So the only thing we need to build is this compiler which will only convert the high level program written in Czech language into the VM code. But before that, before we write the whole compiler, we are going to create the syntax analyzer first, and in that also we have two sub modules, tokenizer and a parser. All right, okay, so the output of the syntax analyzer should be in XML format. Right, so this is what tokenizer will do. It will take the input, the program is the input, and it will give us the different terms or tokens as the output. So this if is one token, this symbol, left bracket, left rounded bracket is one symbol, x is another token, and we have our left arrow, less than operator, and 0 and so on. Okay, in this case the whole of this string is token including the quotes, and the semicolon is token as well. Okay, so I don't think we can split using the space character because it's not always the case that two tokens are separated by space like this one. This are two different tokens, a bracket and x, but they are not separated by space, so we can't really use the logic of using the space as a separator. Okay, we'll figure it out later. Let's just read on right now. So for the tokens we will have five kinds of tokens: keywords, symbols, integers, strings, and identifiers. Okay, and for the keywords, these are the keywords of the Czech language: class, constructor, function, method, field. Symbols, okay, then we have integers, a string constant, and identifiers. So identifiers are like variables and such things. Identifier is a sequence of letters, digits, and underscore. These are the tasks that the tokenizer will work on. The handle the compiler's input, advance the input, supply the current token's value and type. Okay. So we not only want this values, these different tokens, but we also want this kind of tags which will specify the type of that token. So in this case it's a keyword. If is a keyword of Czech language, this bracket is a symbol, X is an identifier, again a symbol, and so on. Okay. And after the tokenizer we'll have a parser. Yeah, before we move on, let's read the pseudocode. So the tokenizer will have this kind of a class or a module which will take the jack program as the input, and it will advance. So this advance is basically moving on with the tokens until no tokens are left, and while has more tokens, get the current token, token classification, current token classification. Okay, get the classification of the token or the type of the token in this variable, then print the type, then the value and the type, print new line and advance. So this will give us this kind of output. Okay, so let's see the parser now. Grammar. So after we run the tokenizer, this is what the output will look like. Now comes the role of the parser. Grammar is a set of rules describing how tokens can be combined. Okay. Right hand side includes constant only. So the right hand side is the terminal and the left hand side is the non-terminal. This is the grammar of English language, but we'll have the grammar of this Jack programming language as well. This is what the subset of a subset grammar of this Jack language looks like. We have three kinds of statements. So we have more than three kinds of statements in Jack, but this is just a subset. So in this set we have three kinds of statement: if, while, let, and the statement again. These are the kind of statement. Okay, and if statement is made up of again if keyword, this symbol, and this expression, which is again a non-terminal expression, so it will again be expanded using this right hand side rule. So this is the constant though, this involves, but this is not a constant. So let's look what it looks like. Expression, this is what the expression will look like. It will have a term and it will either have, so this question mark, I think it means one or more. Yeah, I think it means one or more. So it will either have, the expression either will have just a term, or it will have a term, an operator, and a term. So again, the term is made up of either either a variable name or a constant, and this op is for the operators. So these are the subset of the operators that we have. Okay, I get it. And this syntax should adhere to the grammar, or else it is not a valid syntax. And I think in the building of this compiler, we are assuming that the program that we are inputting to the compiler is always in a correct syntax, so there are no syntactic errors, because we are not going to create the logic for error checking. So we are always assuming the syntax is correct. So this lines of code do not adhere to the grammar, because after this expression and this symbol, it doesn't have this opening curly bracket. So this is not a correct syntax according to the grammar. Passing determine if a given input conforms to a grammar in the process and covering the grammatical structure of the given input. Yeah, so I guess when we try to check if it conforms to a grammar or not, we are also checking if it is incorrect. We are also checking for errors. So yeah, so implicitly we are going to check for errors anyway. Parse trees. Determine if the given input conforms to the grammar. In the process, construct the grammatical structure. Okay, so the parse tree is the grammatical structure. This is again for the English language. For the jack language, the structure will look like this: statement, while statement, 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 let. Okay, and in our case we are going to represent the structure in the form of XML. So by default this XML, or by design, this XML is hierarchical like a tree. So this is the topmost tag, while statement, and inside that we have kind of a hierarchical structure. This is what the final output of the syntax analyzer will look like. It will be just an XML file with this kind of structure, and this is just for the while this code, but again for the programs that we have, in our case it will be much bigger. Parser design. The parser consists of a set of compile x method. Okay, each compile x method implements the right hand side of the grammar rule. Okay. Okay, so this is what the procedure will look like for the compilation engine. Follow the right hand side of the rule and parse the input accordingly. If the right hand side specifies a non-terminal rule like an expression or statement in this case, then call the method for this rule again, so it will be recursive. So they've given an example for the while statement. In this case, first we will call the compile while statement method, because we come across this while keyword. It will look like this. We'll call the compile while statement and place the tag while statement. After that we will place the keyword while, and after that we have a symbol, so we'll place the symbol. After that we have expression, so I guess in this case we'll again call a different method called compile expression, because it is I think a non-terminal rule. So we'll call compile expression. For compile expression, again we have a non-terminal rule term, so we'll call that compile term method. And for compiled term, we'll either have an identifier. Okay, wait. So in this case, although variable name and constant are not kind of the non-terminal rules, but we are not having any method for these two terms, variable name and constant. We are going to create a tag directly for them, so it will be called an identifier. In this case, it's a variable name. Okay, so after the count, I think we'll return from the compile term. So we'll be done with this method. After that, we'll come across this symbol. That means it's a part of this expression, so we'll call op. Yeah, so in case of operator as well, we are not going to have any method. We are just going to place the symbol directly. Again, the same thing for term. So this will happen until our program reaches the last token. Let's skip it. Okay, this will be the final output of the parser. So we'll have to implement this kind of methods, compile methods, and we'll have a class named compilation engine. This is kind of a pseudo code for this method, eat. And by the way, eat in this case, I think it is it too. Okay, so it in this case, it is just printing the tags, I think. Get string if current token is, what is this? The string error, else advance. Okay. LL grammar can be parsed by a recursive descent parser without backtracking. Parser that needs to look ahead at most key tokens in order to determine which rule is applicable. Okay, so in this case, in case of the subset of the Jack language that we have seen so far, it is just LL1, because we don't need to look ahead any more terms. We just need a one term to determine which kind of statement it will fall into. But again, we'll have different syntax in this language which will fall into LL2, I think. Okay, the notation. So earlier we saw this question mark. It means that x appears 0 or 1 times. Yeah, 0 or 1 time. And star in this case is 0 or more times. The font is so small, I can't really see. Okay, much better. Lexical elements, keyword symbols, program structure. Okay, so this is the whole grammar. Previously we saw just a subset of this grammar. This is the whole structure of the grammar. Jack language includes 5 categories of terminal elements tokens. Let me create the project folder first of all. What should I call it? Compiler. Jack compiler. We'll have a main file. Well, we'll see it later on. Each class is structured as follows. It will have a class. Okay. Class variable declaration. It will have this kind of syntax. We'll have a type. Just type. Okay. Subroutine description. Not description, declaration. Subroutine declaration. It will have a structure of this type or this kind. It will either start with constructor, function, or method. After that, it will either have a void or type. Again, this type will have this kind of syntax. It will either be an int character, chr, boolean, or a class name. So the type can be a class name as well, and we'll have the subroutine name. After that, we'll have a left rounded bracket with the parameter list, and right rounded brackets and subroutine body. So this is the whole of the grammar now of the Czech language. So in this grammar, we have this kind of terms as well, including a term starting with a variable name and square bracket, left square bracket, expression in right square bracket. So term can be either of this kind. So in this case, the language ceases to be an LL1 type, and it is, I think it is of LL2 type, because when we come across a term, we will have to check if the second, we'll have to look up the second token just after this first token, which is term. We'll check the token, second token, and if it is of this kind, a bracket, square bracket, that means it is of this kind of term. And yeah, I think that this is it. Parsers design a set of compile method structured according to grammar. Each method outputs some of the parsed XML and advances the input. The parsing logic of each method follows the right hand side. Okay. So as I said earlier, for this syntax, term and subroutine call, the language will be of type LL2. Oops, I will have to reload the page. The parser encounters a terminal element of type keyword in symbol, integer, constant, string, constant, or identifier. It should generate the output like this: a tag xxx and a closing tag. Okay, and if the analyzer comes across unknown terminal, this comes across an input which is of type non-terminal, should first generate this kind of output, then it should recursively output for the non-terminal body. Okay, for example, for return statement we'll have this kind of structure as the output. Okay, so in case of non-terminal elements, we have two cases, in which one case will include this list of elements, and for the second case, if we have this kind of elements of type, class name, subroutine name, variable name statement, or subroutine call, then the parser handles it directly without recursing. Okay, so that means we won't be having any method for this kind of elements. Okay, so this is a type of late statement. Okay, it is a type of statement. So in this case, we shouldn't recursively call any method. We should directly output this kind of structure. Good. All right. Oh, what the heck happened? Oh, I clicked on the link. Okay, so this is the proposed implementation. Check analyzer. Okay, it will take input. If the input can be a file, just a file, or a directory containing different .jack file. So in case when we have a file, we'll have the output as file name.xml, and if it is a directory, we'll have the output. The input is a directory, we'll have one .xml file for every .jack file. Okay, stored in the same directory. Okay, so in this case we don't have to create a new directory. We'll save the .xml files, the output files, in the same directory which was given as the input. Okay, let's start coding directly. So I think first of all we'll create a jack analyzer file. Yeah, we'll call it jack analyzer .py. Yeah, that's correct. if name equal to name, right? Then we'll call main. Oops, I need to do something else before we continue. Okay, it is set. Need this quotes. Okay, it is correct now. So now we need to create a main method. What should we do inside this method? Well, we should parse this system arguments. So to do that, we need the OS module. Is it the OS or the sys module? Let me check. Yeah, it is the sys module. We need the sys module to pass the system arguments. sys.argv. Okay, we'll check if it is a file. File name dot check. Oh, let me get. Okay, I need to use this method. os.path is directory. So let me copy this up to this. let's paste it over here. What's the path, absolute path? This dot arg v1. Is the path is directory. If it is a directory, well, let's not do anything right now. So we'll figure it out later. What do we need to do after we have taken the input? Well, before we give the output, we'll have to create a tokenizer, the compilation engine, and the jack analyzer. Okay, so this will be the topmost module. Jack analyzer will be the topmost module. Then we'll have a tokenizer and the compilation engine. So I think we'll create this jack analyzer. Yeah, we'll create this jack analyzer module in this jack analyzer.py, and we'll have different files for these two modules. So let's say the implementation. Let's read on. This jack analyzer uses the services of jack tokenizer, written according to the jack grammar. So this is the part of the grammar which will be requiring for creating this tokenizer, and this part of the grammar will be needed when we create the compilation engine. Okay, I think we should first create a tokenizer. So what this tokenizer will do, it will just give the tokens as the output. Yeah, right. Handles the compiler's input, allows ignoring white space, advancing the input one token at a time, getting the value and type of the current token. Okay. Constructed code has more tokens, advanced token type. Right. So let's create file called jack tokenizer.py. Okay, inside this we'll have a class called Jack Tokenizer. Okay, it should has more tokens, advanced token type. But this tokenizer, what should it contain? What should we pass to the tokenizer? I think we'll pass the .check source code file as the input to this tokenizer. Yeah, so it will have the input file as input file stream. What is a stream? What do they mean by stream? Yeah, it doesn't matter. So let's see. We'll have the file as input. Let's not call it file. What should we call it? Source. No, it will be code. No. Let's just call it file. And I think we can't use this file directly because it is a keyword in Python. So what should we call it then? File, source code, input file, jack file. Yeah, let's call it J file. Yeah, it sounds good. J file. Has more tokens. Okay, I will figure out this later, but let's open up the jack analyzer. Oh wait, we already have it open in the buffer. So in this jack, let's see. Let's write the logic in the else. So before we use the module, we need to import it. So how do we import it? Import inject tokenizer. How do we import it? I need to check it out. Can I directly import this jack tokenizer? What the hell? Well, you know what? From jack tokenizer, import jack tokenizer. I think this is the correct syntax. From jack tokenizer, import jack tokenizer. How to import a class from another Python. Now I think we can use the tokenizer like this. Check tokenizer and we'll pass the path. Wait, we don't need to pass the path, we need to pass the file. So before we pass it, we'll have to open it up. Right? Should we not? Should we pass the file descriptor, or should we pass the path? What are we doing in this case? Well, for the code writer, we're not passing anything. And what the hell? Let's just pass the file path. Not the path, the file descriptor. So we'll get the descriptor first of all. J file equal to open the path and open it up for reading. Okay, this seems correct. Right. I guess this is correct. We'll pass this file descriptor J file to the tokenizer. J. What the hell? Is my internet connection down or what? They say that the connection is unstable. What the hell? Well, my internet connection seems alright. Then why is it showing me that the connection is unstable? Okay, it seems it is stable now. Okay, let's continue. What did I do? I need to pass the check file descriptor to the tokenizer. Okay, let's try to run this. Before that, I need to write the cbank user bin python 3. I guess this is correct. Let's check this file, user bin environment. Okay, user bin and env. Let's hope this works. Check analyzer. Oh, chmod plus x. Check analyzer. It should work now, but we'll have to pass a file. Let's pass array test square main dot check. Wait, we already have the XML output. What the hell? Why do we already have the XML output? I natural way to test your syntax analyzer is to have it pass some representative to Jack program. We supply two such program. Okay. Expressionless version. How are we supposed to test it? Single design to test how the syntax analyzer handles array processing. Okay, we have a source class file, a tokenizer output file, and a parser output file. If you want, you can compile the supplied using the Jack compiler, then use the supplied VM emulator to run. This activity is relevant to the current project, however it serves to show that the test program are not just plain text. That is alright, but how are we supposed to test these files? Test your tokenizer. How do I test it? Got that. For which source file have your tokenizer test program, give the output file the name xxsd. But okay, but in this case we already have main dot. We'll have to give a different name to our output file so that we don't lose these files. Let's just try to run the program for now. We'll worry about the naming later on. Okay, expected an indented block. Where did we miss? Check analyzer. We already have an indented block. Why is it giving us an error? I see. Should work now. Good. So we don't have any errors, so let's continue writing the program. So writing the tokenizer, let's go back to the tokenizer. It should have a method has more tokens, advanced, and a token type. So I don't think we need to create this has more token method in our case, but we need to create advanced method, I guess, and a token type method as well. This method will return this 5 keywords, returns a type. Okay, so let's create the token type method first of all. Token type, what should we pass to the token type method? Well, we'll pass the current token. Right, returns the type of the current token. Before we write this method, we need to pass the tokens. So seems we do have to write this advanced method first. It gets the next token. Let's write it. Definition advanced. Okay, what should this function do? It should get this file descriptor, and it will continue passing the syntax. So now comes the meat of the program. The tokenizer ignores all comments and white space in the input stream. Ignore all comments and white space in the input stream and serializes it into language tokens. So what is this advanced method does? It will take this file and it will read the tokens, but how are we going to get the tokens? Should we read line by line? I think so. And in this case we should ignore the comments. So let's try to read the file line by line. So we can use, I think, for line j file. First of all, print it. Tokenizer dot advance yeah, forgot. I should write self.j file. Okay, this should work now. Let's try to run it. Good, so it gives us the output. Now we have to get rid of this empty lines as well as the comments. So let's do that. If line What kind of commands do we have in the Jack language? We'll have to read the documentation. Where is the documentation? Yeah, so we have three kinds of commands in this Jack language. It either starts with forward slash and asterisk, and a forward slash and two asterisks, and it ends with, wait, I think this is a typo, or is it? Shouldn't this be star star asterisk? Well, it doesn't matter. But so this two block command, what the fuck? Why do we need a block command when we already have this API block command? This is so ridiculous. They could have gotten away with just using a block command. Well, it doesn't matter. But here's the thing: if we have this kind of command, that means there is just wait, this is an inline command. So what does that mean? Can't we use this like in a can't we have just a comment, an inline comment in a single line? Like, does it require that it should contain code as well? Because that is basically what an inline comment means. So this language is ridiculous. Yeah, so we can have an inline comment without a code part. Okay, so the inline comment is easy relatively because we don't need to take care of the new other lines, because if it is an inline comment, that means we have comment on that line only. But in this two types of commands, we might have multiple lines containing the comments, so we'll have to take that case in mind. So let's see, can use if line starts with, let's see, if it starts with this, well, not going to do anything right in this case. In this case we shouldn't really print, so let's print only when this case is not, when the line is not a comment line. Well, you know what, we should do this. Can we do this? Do we have a negation operator in Python? Yeah, we don't have a negation, we have not. So not, if not, then print the line. Also, well, if the line starts with this forward slash and asterisk, that means we have this kind of comment. So in this case, we can't really do anything, and we also have to keep track of this because the comment might end after multiple lines. So I think let's get a variable name, a boolean variable. Comment comment code comment lines. So it should be false by default. And if the hell, I forgot the elif syntax. Okay. Line starts with asterisk forward slash and asterisk. In this case, we should change the state of comment lines variable to true. So now what we can do here is and not comment lines. I hope this is the correct syntax. And we should also have a condition near the line. Do we have an ends with or something? I don't think so. We have that kind of method. Method, string methods, string methods, strings. String methods ends with, returns true if the string ends with the specific value. Okay, so wait, but should we directly use the end with? Yeah, before we use this line, let's just trim it. So we'll do strip. Yeah, so it will strip off all the white spaces. And here it should be ends, okay, ends with, if it ends with colon and forward slash, then in that case we'll toggle this false. Good. So okay, we also need to take care of a case when we have an empty line, and let me check if the line is empty or not. I think I did it in this file. Check if the line is empty in Python. I think we should check for new line character. Let's just Google it for not line strip. Okay. So not line, well, it is already stripped, so we can just use the line. So this should remove all the empty lines as well as the comments. So let's check if this works or not. Again, we haven't gotten rid of the inline comments, so they should still be visible, but we should be getting rid of this comments. So let's see if this works or not. Okay, cannot assign the function call. What? Why can't I use strip on line? This should work. Oh wait, this J file, am I passing the file correctly or not? I am opening it up and passing the file descriptor to the tokenizer. Yeah, I'm passing it the file correctly. Damn, why can't I use it like that? So we do have the strip function. Try to use it. What? Can't I edit it? What the hell? This should be editable. Okay, this is weird. Can't assign to function call. Okay, do it over here then. Let's check if this works or not. Oh, this worked, but we are not getting any output. Why are we not getting any output? Yeah. So this condition is not really working. Let's get rid of this comments. Okay, let's see if this works or not. Good, so this is working, and this should only strip out the inline comments. Yeah, so it did strip out the inline comments, but we still have this kind of comments, the API comments, to get rid of. So let's figure out how to get rid of those now. So this was not really working. So if line not, it doesn't start with base and comment line is true, this is false and not line. So let's get rid of this case for now. Okay, so this seems to be working. I see now. So what I really have to do is change this line. This doesn't really strip the original line, it just returns the strip line. So we have to do this. Now we can check for this not line condition. And I think it is safe to uncomment this lines as well. It will work. Oh well. Let's not uncomment it right now. Let's try to print it. Oh, oops. It got rid of all the lines. What? And it seems like we just have the empty lines as the output. So what really happened here? Wait. So this might work. Good. You're getting the correct output. And now we only need to get rid of this block comments. So let's do that by uncommenting this lines. What? It didn't get rid of this comment. Oh wait, I know why. So what we really need to do here is should move it down here, and this should be LF. Okay, we have gotten rid of all the comments as well as the empty line. So seems good. Okay, let's continue. What should we do after that? Okay, now that we have parsed the line, gotten the line, we don't really need to print it. Now we need to parse the tokens from that line. Okay, this is the hard part. Alright, so in this case we have 5 kinds of tokens. It's either a keyword, a symbol, integer, constant. So I think we should have this inside an array or something. Yeah, I think we should have this inside a list. So let's see, where should we write it? Let's have a self dot, what should we call it? Keywords. This will have all the keywords. Can I copy this? It seems I can't copy it. Yeah, we have it over here. Good, I can copy this at least. We have the list now. I think it is safe to first split it by space, using the space. Should we not? So the only case where we might have two tokens which are not separated by a space is when one of the token is a symbol, I think. Is that true? Because in this case we might have point, and immediately after that, without a space, we can have a curly bracket. So yeah. Right. So let's see. Let's do line dot split space. Okay. Print T for T in let's see if this works or not. Ah, good. So it did work. Oh, so this is really messed up, but because in this case, how many tokens do we really have? This is an identifier. Let's check the grammar. Where was it? In this case, do is a keyword, but this is an identifier, I think. Okay, what is the definition of identifier though? Okay, so I think we should be using regex, because if we split using the space character, it will split the string as well. So it should be a single token. This string, the average is, it should be a single token, not separated 3 tokens or 4 tokens. So we can't really do that. Also, this bracket should be a single token, but I'm not sure if this output dot print string should be, wait, so it is really a subroutine call. So let's check the grammar. It's neither, it's not a keyword, it's not a symbol as well, not an integer constant, neither a string constant. Okay, so that leaves us with an identifier. So this is really an identifier. But here's the thing. Yeah, so this is really a class name followed by a subroutine name, right? Should it be a separate token or something? I will have to check it out. Oh, okay, so dot is a kind of symbol, so that it means it's a different, yeah, it's a different token in and of itself, so it should split it from this. So this should be one token, this should be the second token, and the print string should be the third token. Yeah, I get it now. And this is an identifier, this is also an identifier. Okay, good. Okay, so I get it. But now I think we need to change our method of parsing the string. We can't really split it by this space character. So what should we do instead? Let me check the definition of split. Split. Where is split method? Python strings, string methods, and split. Okay, so I think we should be using regex. Okay, before we start using the regex, let's see what we really need to do. So let's say if we have a line now, we need to check if it contains keywords, symbols, integer constant, string constant, and identifier or not. And while we are splitting the line, we don't really care if it is a keyword or an identifier, right? And I think we do care, because an identifier contains digits and underscore as well, but not starting with a digit. But keyword doesn't contain it. Well, still a keyword is part of an identifier, so we don't really need to So let's just keep these two lexical elements in one box for now. And then there's integer constant. Well, we can also keep it inside one box. After that, we have the symbols. This is one box in and of itself. Let's just copy this and store it in an list. What the hell? Why can't I copy it? This what? Oh, yeah, I can. Well, dot symbols. Okay, good. I hope this list contains all the symbols. Let me check. Yeah, I think it covers the whole array of the symbols. So and there's the string constant as well. So the string constant is basically a string starting with double quote. Wait, not including double quote or new line. So you can't really write it in a new line. It should be in a single line, the string constant. But should it be just a double quoted line or a single quoted line as well? I think it is a double quoted line. So now what I really need to do is check if this elements are present in the line or not. and I need to separate or split the lines in terms of these different elements. Okay, how do I do that? And also it should maintain the what can we say, the order of the elements. So okay. Can we use this method find all, because it does return the array? And to this find all method we can pass the regex string. Can I use this list inside this regex? Let me try to Google it. Regex use words from list path. Not really this one. How regex, how to match. Not why are they using this join? Seriously? Go to hell. I'm going to copy this code and run it here. What? What happened? Oh, okay. I see. Copy. Okay, so this is what the temp looks like. What did that do here really? Okay, so this is the regex, I guess. This is confusing, man. Yeah, search in list. That's what I need. Filter. Oh, good. R.match. Let's check this method filter. Should be in the list, Python list, methods. No, it is not here. Let's not really a list method. Filter Python. Well, this is not really what we need. Let me try to write the pseudocode. Maybe it will be easier afterwards. So let me try to write the pseudocode. So let's say what do we really need to do? First of all, we have a line, right? What do we need to do with this line? We need to do matching, so we can so does any line dot sub part of it equal to, I don't know, maybe an identifier? Does it match the definition of an identifier? And if it does, well, it should be a token, right? If line dot sub equal to symbol, well, in that case it should be a token. Well, we already know this, but we should do this comparison in order. So we can't return the tokens in an unorderly manner. It should return the tokens as it appears in the line. Okay, so can we have this kind of function? Line dot find all where we suppose we have a regex here and we pass the line to it, right? This is how we can use the finder, right? Yeah, we pass the string to it. Good. So let's say line dot find all, not really line, it should be re, but it doesn't matter, it's just the pseudocode. Find all regex line. Now what this regex should contain is well, it should match, yeah, so match identifier, match symbol, match int constant, match string constant, and match, and we already have the identifier, match keyword. Yeah, so this is what the regex should look like. It should match this different categories of elements. Okay, so we don't really need to have different regex for keyword, identifier, and the integer constant, because what really they are basically a sequence of characters separated by space, right? Yeah, a string of characters separated by space, but this string of characters should not include the string of characters should not start with a, okay, let me write it down. Okay, so string of, not really a string, sequence of letters, digits, and underscore. Okay, but it should not, they shouldn't start with a digit. Wait, but integer constant does start with a digit. Well, so we'll have to separate the integer constant. So this is just for keyword and identifier, I guess. Shouldn't start with a digit, right? And what else? Shouldn't, it should not contain the double quotes, right? Shouldn't contain double quote. Yeah, this is the definition of keywords and identifier. Now for the integer, well, let's just an integer. What else do we have? We have a string constant. Double quotes and sequence of characters not including double quote or new line. Okay, and it ends with double quote. This is the definition of a string constant. And finally we'll have a symbol. So a symbol, well, we have a list. So any character matching a character from the symbols list. So this will be the definition of symbols. So this is pretty much it for the regex logic, at least. Now we need to figure out how to get this regex. Can I pass a list? Let's see. In the what if I pass this list over here? How do I pass the list? How to pass a list to a regex in Python? Make a regex that matches if any of our regexes match. Okay. I got it. Okay, I see. Yeah, this isn't really what we need. Capture, yeah, we are using this capture in group here. Capture. Why is this plus here? Let me try to run this example. Oops. Python 3, Python 3. Okay, so let me copy this. Okay, instead of my string, let's provide the txt. And instead of joining the regexes, let's join the list. List. Okay, let's see what happens now. What happened? Some regexes match, yeah, but so what? Mm, mm, mm. Okay, so it returns a tuple. Why does it return a tuple again? What does this really mean? Brackets and plus. Oh wait, this is just concatenation. So what does an empty bracket mean then? Let's check the combined. Let me print the combined regex. Okay, in the okay. Okay, I see what this does. Capture and group. How about this one? Good. Yeah, this is exactly what we will need. This is the regex that we need. This list separated by, yeah, they were already separated by the yeah, so I think we have what we need. Let me check how to use this join method. Also, I think it will be really helpful. Okay, I get it. We pass the iterator here and the separator here. Good. So we don't really need this, and this as well. This will work. Good. It returns the in. Why does it return in 3 times? Okay, this is messed up. I see, because in is 3 times. Okay, I get it. So we need to separate it by space. I think we should use this. Dash s plus dash s. So now we should have thus the and in as the output. Yep, the and in is the output. Wait, why is it matching this though? Even though it doesn't contain. Oh wait. Okay. So in this case it doesn't match. How about now? But if I do this, oh wait, is this the correct way? I wonder. No, I don't think this is the right way. Yeah, we should have space. So this is going to be a long regex. I think I should save this one. Wait, but this is not really the correct one. So let's not save it right now. And I will be back in a bit. So mm, 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 mm. I was thinking maybe, yeah, so we are going to have different regexes for this different cases inside a list. So for, let's say for this case where we have symbols, the regex will be simple because don't need to check for the space, because we might not have the space uh, for after or before the symbol. So in this case we should check for just the list. So let's say I copy this. Let me paste it here. Sim equal to this list, right? So sim now let me change this. Let's have characters like this. op.tp and tp. Let's see what it gives us back. Ooh, what happened? What happened? Okay, this still works, but why are we getting an error? Oh, is it? No. I see. We need to escape some of this, I think. We are getting this error maybe because some of these characters are does have a spatial meaning for this regex string. So I think we need to escape some of these characters. Or should we escape all of them? By the way, we have space over here. Why do we have two commas? We have here as well as here. Let me check the documentation. Nope, we don't have two commas here. Mm, we have this character, not comma, but this straight line character should be here. Why didn't it show up then? Doesn't matter, I will edit it. Okay. Okay. Let's see. Let us fix this one. It should be this. Yep. So let's check. We have open curly brace, close curly brace, open rounded, close rounded, square square, dot, comma, then we have a semicolon, after that plus, minus, asterisk, forward slash, and percent, then this straight line, less than, greater than, equal to, and the null character or the tilde character. Okay, that's all, and we need to escape some of this. Should we escape it over here? Same as S for S in sim. Oops. What really happened? Oh, okay. Can I do this? No. Well, yes, C equal to, okay. Well, still we have the same problem. Oh wait. Yes, plus this. Okay, but we have a problem. What the heck is this returning? Oh, wait. It did return all the symbols. Good. This is working. This is working. But it didn't return the dot character. Wait, why didn't it return? Yeah, I know why. We have space over here. Let's remove the space. Okay, also we need to change the status. So this might work now. Awesome. So it returns dot as well. Great. So this is the regex for symbols. Let's save it. Why should we save it? Yeah, this one. So this is the regex for the symbolic list. Now we want the regex for let me check. Mm, ch- 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 mm, mm. Yeah, well, let's try to get write a regex for keyword and identifier. So for keyword and identifier, we have a sequence of letters, digits, and underscore. Shouldn't start with a digit, should not contain double quote. But this should be easy. At least I hope so. So what should we do? Sequence of letters, digits, and underscore. So it should be this, I guess. Returns a match where the string contains any word characters A to Z, any digits, and the underscore. Yeah, exactly this. This is the definition of the identifier. Well, but it shouldn't start with a digit and shouldn't contain double quote. Okay. Wait. This is going to be a problem because you see if we use it, it might tokenize this as well, but it should be a string constant. not an identifier. So what should it be then? Which regex should we use? So we want to match the symbols. You want to match a sequence of letter digits and underscore. It shouldn't start with a digit, and also those sequences shouldn't be inside a double quote. Okay, how are we going to do that? So yeah, no. So we should check if this any of the words have a matching opening double quote or not. If there is a matching opening double quote, then we shouldn't pass it as an identifier. Right, this seems correct, but how do we do it? Set the regex. Signals a special sequence. Okay. Starts with. Yeah, maybe we can use this starts with. But in our case, it shouldn't start with. So is there a negation or something? In our case, it shouldn't start with the quote. So let's see. So let's say the string is like this. Let me convert it to single quotes. We have a double quoted string as well. I am a string. Right. Now in this case, we should pass the rain, OP, TP, in and Spain as the identifier, but not I am a and string. Yeah, so let's write the regex for it. Let me comment this and copy it over here. So what should we do in this case? let's write that as x. Suppose if we use this not yep dot star directly. Okay, so this might work. Oh wait, what did it return? Oh fuck, it returned the whole string. So it does the no. It should return the word, not individual letters. Well, what if I use space as the separator? Oops. Oh yeah, I know why. Star. Okay. Awesome. But we have space here as well. What if I remove this space? Alright, in this case it still returns this. I don't know what that is. Regex to return word from a string Python. Well, hello anti-party. And you know how it is with programming. You cannot stop yourself from having too many tabs. Actually, and actually it hinders my navigation. I have to carefully click on the tabs so that I don't cancel or close them. If I just press this, it will close the tab. Are you a Python developer? Plus extracting words from a string in Python using the array module. Find out, take two parameter, first pattern to be searched. Ignore case, text it is record. Okay, then it will match for chin and y only. To extract only the names of the fruit vegetable that were bought, you can create a pattern using the class containing only characters. Okay, this plus operator denotes multiple occurrences of this character class. So I think I should use plus over here. Instead of star, let's use plus. Oh, good. So we are getting the words in this case now. Okay, one step is clear. Now we need to remove these words which are inside the quotes. We don't need those words. So how do we extract them, or how do we stop them from coming in the results? Can we use this? So this will check if we have a quote or not. Dot start quote dot star. Wait, we are getting the whole string now. Hey, anti-party, do you have any experience with regex? How do I ignore the words from the string? Wait, but why is it giving me all the whole string in this case? Dot star. Yeah, maybe it is because of dot star. What I really need is I need to ignore all of these words which are inside the opening and closing bracket. Sorry, the quotes. Wait. Can I do this? Plus dot star and quotes. So this might work. Let's see. Nope, it didn't work. What it really did is it took out I because, and it also took out the. Whoa, why did it took out the? Let me check the reference again. Starts with returns a match for any character except A, R, and N. Okay. Well, I don't really need this. Awesome. Wait, I'm still getting a string, but it did take out I. So it seems we are on the right path. Why did it ignore this I, but it let all the other words in? Wait up. Let me remove this and see what it returns. Nope, it didn't work. How about this one? It ignored all the words. Nope. I don't want you to ignore all the words. I want to ignore. There was something called regex playground. not codes. Good. Not codes. Dot star. Oops. Dot star. So why is it getting rid of this the yep, this is what we want. This is in Java, but I guess it will be similar. Dot, comma, what the hell? Match double quote. Okay. Yep. For Python. I'm glad there's a question for it. Comma dot plus question mark. Okay, what the hell? Wait, let's copy this and let's paste it. Let's paste it here. It didn't get rid of the... Well, this question is exactly the opposite of what we really want. In this case, the questioner is asking to extract this part, which is inside the code. Well, maybe we can use this regex for this character of sequence. Yeah, we'll use it when we need to write the regex for sequence of character. And you know what? Let me copy it so that we don't lose it. Good. Whoa, what? The heck is this? Holy hell. if I use it like this? Well, run an empty array. Okay, so it seems like this is not really what we need. What if I do this plus? Nope, this might not work as well. Everything inside double quote in a single quoted string regex Python. I want the opposite of this thing. I want to remove everything which matches this regex. No. This didn't even work. How about this one? Oh, great. So it is matching. I am a string. But let's see. I want to remove all of this. So can I use this? Yeah. Well. Wait. Why can't I just use it like this? Yeah, I can use it like this. But how about this? Oh, what? Do I need to escape it? I don't think so. You know what? Let's try to use this. It returns empty string. How to negate the regex? What? No, this is not. Oh, good. Seems promising. Negative look ahead. Okay. Let's try to use it. How was it? Dot star. Oh, great. No, not great. I didn't remove this part. Uh, I don't get it. What is negative? Look ahead. Rejects. Icon. Look ahead are zero width, meaning they do not consume any characters. For example, that was what? How to ignore? Ignore what? A string matching regex in a string. What? What am I typing? Yeah. Mm-mm. Okay. Ooh, what is this hard? This question mark too. Question mark. Oh, question mark is nowhere to be found. Why? Why is there no question mark? What if I do dots? I got rid of all the string characters. Why the hell is this not working? How about this one? Wait up. No. Interesting. Return the. Why did it return the only? Let me copy this regex in the playground. Oh, I see, I see. This matches the beginning. So I get rid of this. But yeah, so it got rid of this. Okay. Oh man, regex is hard. We are back again. Should I also use this padded something or what? I will try to use it. Oh wait. Oh. Why did it select I and A? This is interesting. Not. Correct. I gave up. This is fucking hard. Oh, yes. Oh, wait. What if I do it like this? Mm-hmm. Yep. Dodge stuff. No. Oh. This matches this string. Nice. What if I do this? Yeah. So what I really need is anything but this. How can I do it? Huh? Can't use this or what? This doesn't seem to work. How to return anything but matching regex Python. Oh. You know what? We can use this for extracting this. So let's save it. Get rid of this G. Okay. How about this? What? So we know we need to use look ahead because it says right here that negative look ahead is indispensable if you want to match something not followed by something else. So sure, we have to use negative look ahead, but I'm not really getting it. What I need is match a word. How do we match a word again? Mhm. Oh yeah, Python rejects matching pattern not surrounded by double quote. This looks like अच्छा नहीं करेक्टर बस। Oh, good, 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 good. Mm, just need to grab this now. So what this does is grab any word or any word which is not preceded by quote and so this gets all these words. Yeah, let's save this one. Meaning of this. Mm, grab any word which is not preceded by quote and words Mm, 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 mm. Mm. In this context, it means select a word which starts with title, but it doesn't start with quote, and it doesn't contain spaces, one or more, and it doesn't end with quote. In our case, instead of title and this, we have a string which starts with how about this? You know what? This solution might also work because we might not even have. No, we do have. We might have. Hmm. Whew. Hmm. You know what? This is it for today. Hmm. We'll continue with this issue in the next stream, I think. Right then. I'll see you guys in the next stream. Bye bye.